Okay, and we are live, you guys. Yeah, it is Wednesday, the 25th of March. Crazy, huh? I know. Well, we're going to do this. And you guys, if you keep working and keep doing your homework and showing me good answers with work, you're going to get a decent grade. If you're lazy, not doing anything, then bummer for you. You might have to take the course over, because how do we give credit for kids who don't do anything? Anyway, today is, and spread that word around, because there's a few of you not doing anything. 3/25, and of course 2020. Wow, we are in house arrest, aren't we? Locked down. So first of all, real quick, show you last night's answers from last night's homework. Hopefully you guys have done this, but if I take a look at the homework, here are the answers. It doesn't show the work, but you need to do that. Okay, so no, number one, it does not work. That point is not in the shaded region. 3, yes, that point is in the shaded region. 5, that point is yes in the shaded region. 7, here's the answer, shaded. 9, here's the answer if you shade. 11, here's the answer, shaded. 13, here's my answer, shaded. 15, here's my answer, shaded. I just solve for y. Y is greater than x minus 2. Here I just solved for y. I got y is less than a negative 1/2 x plus 2, and I shaded it. And then in 19, I just solved it by intercepts. That was the easiest. If I cover that up, I get a 3, put a 3 there, and if I cover it up, I get a 6. So I did by intercepts, and I picked any 2 points. So one point I picked was 5, 2, which stands for 5 digital and 2 cell phones. I picked another point, could be any point. I picked 3, 5, yeah, and that represents 3 digitals and 2 cells. Okay, so that's the homework. Real quick, again, I want to emphasize to you guys that if you're doing your homework, you're going to get a decent grade. If you're not doing anything at all, and you tell your friends who are lazy that they will probably have to take the class over, and that will suck. But here is a great list of all these kids who are doing such a great job. I'm proud of you guys. Very good. Okay, so now today's lesson is actually pretty easy, because we're going to shade, and we're going to shade again. So we're going to do two shading graphs on the same graph. Okay, so first of all, let me show you an example. Okay, what we want is to do problems like this. So what we want, we're going to shade and shade again, and where they overlap, we're going to get is our answer. Okay, where they overlap is our answer. So let's take a look at how to do that. So example 1. If I had this graph, y is less than or equal to negative 2x plus 4, and I had a y is greater than or equal to 2x. Okay, so first of all, is the point negative 1, negative 3 a solution? And is the point negative 3, oh, positive 3, sorry, my bad, negative 3, 3, that's a positive, a solution? I don't know. So there's 2 ways to do it. One way is to graph it and see if it's in that double shade region. The other is just to plug in the points. So let me first show you a way that you can do it without graphing, and then we'll come back and graph. Okay, so I've got 2 equations. Equation 1 is my y is less than or equal to negative 2x plus 4. And my second equation, equation 2, was a y is greater than or equal to 2x. Okay, so here's how it works. If it's a solution, I should be able to plug it in. Every point has some x and a y value. If I plug it in, I get a true statement, then it's got to be a solution. Okay, so if I plug in negative 1 for x right there, and plug in negative 3 for y right there, let's see what I get. So if I plug those in, and I would get something like a negative 3 is less than or equal to negative 2 times negative 1 plus 4. Negative 3 is less than or equal to a 2 plus 4. Negative 3 is less than or equal to 6. That's true. That's true. But it has to be true for both, because it has to work for both systems. Okay, so if I plug it in, same point. We're doing this one right here. Same point. Plug it in. That's my y value. That's my x value. I'd go negative 3 is greater than or equal to 2 times negative 1. So plug that in for my y. Plug the negative 1 for x, and I get negative 3 is greater than or equal to negative 2. Is that true? No, that's not true. So that's false. Has to work for both. So this point does not work. So no, it isn't Is -1, 3 a solution? No, it's not. But maybe -3, +3 is. So we'll do it again. So I can take my point, and I've got my equation 1, which is my y is less than or equal to -2x plus 4, and my other equation, which is a y is greater than or equal to 2x. And let's see if the point 3 is a solution. That's got to work for both. Okay, again, that's an x value, that's a y value. Let's plug it in. 3 goes in for x. Oh, that's a -3. Dang, I hate it when I make mistakes. That's -3. -3 goes in for x, and +3 goes in for y. So let's see what happens. So I'm going to plug in my 3 is, I won't use my other color. 3 is less than or equal to -2 times a -3 plus 4. I get 3 is less than or equal to 6 plus 4 is 3 less than or equal to 10. Yes, it's true. I like that. Okay, it works. Let's check the other one. Plug that in for y. That's a y value 3 greater than or equal to 2 times. Plug that in for x. -3 is 3 greater than or equal to -6. Yes, it's true. Okay, now that's one way to show these points are correct. The other way is just to graph it, which sometimes is easier just to graph it. So I'm going to graph it and see what we get. So get my ruler out, do my XY axis. Okay, there's my XY axis. Okay, I'm just going to graph it. Okay, so let's check it out. So I'm going to use two different colors. Okay, I'm going to use blue for this one, and then I'll use red for this one. Okay, so start at +4. 1, 2, 3, 4, right? And then I have a slope of -2, -2 over 1. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. It's a solid line because I see the equal sign right there, solid line. So I'm going to go ahead and just graph it in. Again, if I get going too fast, you guys can pause this any time. And it says less than, so less than is below the graph, so go below the graph. Okay, there you go. Okay, there you go. Shade it all in. Awesome. Now the second graph, let's check that out. So second graph has a +0. That's an invisible number. 2 over 1. We'll do this one in red. Start at 0. Hopefully you can see the red. Up 2 over 1, because that's my slope. Up 2 over 1, down 2 back 1. Okay. Graph that in. Okay. It says greater than, so I'm going to shade everything greater than. Okay. Now, here's the deal. Let's check out the first question. Okay, shaded. I shaded. Okay. Oh, greater than, yeah. Above the line, yeah. So here's the deal. Let's take a look at my 2 points. So one point was at -1, -3. -1, -3 is right here. Okay. Okay, that point is a solution for the blue graph, but it's not a solution for the red graph. That's why that's a no. Let's take a look at the other point. The other point's -3, 3. 1, 2, 3, 1, 2, 3. This point is in the overlapping shaded region, so it's a solution for both. So yes, that's true. Now, if I take a look, here's what the lesson really is all about. Okay, if I take a look at where they overlap. Okay. So the place where they overlap is all of this. I'll make that darker than the rest. Let's see, what kind of other color do I have around here? Alright, let's see if I can make this good and dark. Okay. So, really shade where they overlap. Which is right in here. Okay, where they overlap is right in here. Okay, and that is a lot of points. So it's all of these points. In fact, there's an infinite many points that all work. So there's no way you can list them all. I mean, I've listed only one that works, but there's a million, billion, gazillion, infinite amount of them. So that's why we shade. So we shade one region, shade the other region, and where the two shadings overlap is the answer. So today's lesson, we'll shade again, and then where they overlap, we'll make darker than the rest. Okay, so this is the solution where the double overlapping shading works. Okay, let's move on to a second example. Okay, all right, example number 2. All right, example 2 is this. If we had a y is greater than or equal to 3 and an x is less than 2. All right, and this time we want to find the solution. Well, the solution's a lot of points. So let's graph it. There's no way we can give one answer. There's a bunch of them, so let's graph them both. So we're going to graph, find the solution. We're going to do it by graphing. By graphing. So y is greater than 3. Let's see. Let me do that in a different color. Let's do that in blue. Okay, y is greater than 3. So we've got a 1, 2, 3 is here for the y-axis. Solid line because it's got the equal. Okay, if it's greater than, I shade everything above it. So just everything above it. Greater than, shade everything above it. Okay, pretty easy. Less than 2. Let's see, less than 2. I'm going to go to 1, 2. It's a dashed line, so I'll make it. That's an x equals. Get your dash like that. And it's less than the shade everything on the back side of it, because less than means like the -1, -2, -3. Okay, so our solution though is really simple. It's where the two graphs overlap, which is this region, all of this region in here. Okay, so by just doing the shading, you've shown all of the answers. So my answer is where they overlap. This is my answer, is this shading region. Okay, it shows all of the points that work for both constraints. All right, not too bad. You graph, you shade. You graph, you shade. You find out where the shadings overlap, and you got your answer. Okay, not a bad, easy day. Okay, let's look at the example number 3. Okay, example 3. I have this problem. Okay, I have a 2x plus a 3y is less than 6, and I have a y plus 2x is greater than or equal to 1. Okay, so I'm going to have to graph them. So to graph them first, I need to solve for y. I need to solve for y, so I have a y-intercept and a slope. Okay, so equation 1, I've got a 2x plus 3y is less than or equal, no equal, less than 6. And equation 2, I have a y plus 2x is greater than or equal to 1. Okay? Alright, so let's solve for y. So to solve for y, let's get rid of the 2x. So I'm going to get rid of the 2x by going minus 2x minus 2x. I'll have a 3y is less than a 6 minus 2x. You can't subtract those because those are different. That's an x, and that's a whole number. Solve for y, I got to divide by 3 everything. And so I get a y is less than 2. 6 divided by 3 is 2. And that's a slope, minus 2/3 x. Okay, I'll graph that in a second. Okay, example 2. Or equation 2, let's graph that. Minus 2x minus 2x. I need to solve for y. I've got a y is greater than or equal to a 1 minus 2x. You can't subtract those because that's an x and that's a whole number. Okay, now I can graph them. So let me go ahead and put my graph in over here. And I can squeeze it in down here. Okay. And there we go. I will graph or shade the first one in blue. Equation 1 in blue, so start at 2 because that's my y-intercept. My slope is down 2 over 3, down 2 over 3, down 2 over 3, down 2 over 3. There's no equal sign, so it's a dashed line. And it's less than, so just shade everything below. Okay. Second graph, let's do in red. Okay. Start at 1 because that's my y-intercept. Invisible number, For slope, 2 over 1. So we'll go down 2 over 1. We'll go down 2 over 1. Okay. I have a solid. I have an equal sign, so it's a solid line. So I'm going to go ahead and make it solid. Like that. This says greater than or equal to, so I shade everything above the red line. Okay. I like using different colors. It makes it better if you guys do use different colors. I would suggest that. Different colors make it nice. So then, where do they overlap? Well, they overlap in this region and here. So I'm going to take my pen, make that region, all of that region, my answer. So where I am overlapping, I double shade and I make it darker than the rest. That is the answer. The answer is the shading where it overlaps. Okay. Alright, last but not least, okay? Let's look at a problem, okay? In fact, we'll do number 11 for you, because you're going to have to do 11 anyway. But 11 says, come up with the equations. Well, I can do that. So 11, I need the equations. So there's two different graphs. There's graph 1 and graph 2, okay? And, of course, every line is of the form y equals some mx plus b. We know that. Slope, y-intercept. So graph 1 should be a y. But take a look at 1. I'm not going to put an equals because it's really greater than equal, because everything's above it. Greater than or equal to, because everything is shade above. So here's graph 1, line 1, everything's above it. So it looks like the slope is up 1 over 1, up 1 over 1. So I'm going to go 1 over 1x. I don't need the 1 over 1, I know, but I put it anyway. Plus 1. Okay, there it is. Line 2. Let's see. It looks like it is a less than, but not equal to, because everything's shaded below line 2. Y is less than, but no equal to. See the dashed line. And it looks like its slope is down 1 over 1, down 1 over 1. So down 1 over 1x plus 1. Okay, and that would be my answer. That's all I have to do. So here's your homework for today. Okay. I want you to do on page 155. I want you to do 1 through 12 all. It's not. I just did number. By the way, I just did number 11 for you. 1 through 12 all. Okay. On number 1, you just plug it in. You could graph it if you wanted to. That's fine. That's another way to do the solution. Number 2, just plug the numbers in. It has to work for both. You do a true statement on both. 5, 6, you're going to graph and shade. Use different colors if you can. 7, you're going to graph. 7 and 8, you're going to graph and shade. 8, we actually did 8 in the notes, but I'll let you find it. And 9, 10, and 12 come up with the equations. Okay, good luck. There will be, now don't panic, there will be, you ready? A test tomorrow. But here's how the tests work. Are you listening? I will show you the test. You work on it. You send me your answers. The next day I will show you my answers and you can correct your test. That means everybody can get 100%, but you must show work, okay? Everybody can get 100% on the test tomorrow because, or on tomorrow, because I will on Friday show the answers. Okay, so any questions, text me. Keep moving, keep working hard, okay?